class, we talked about finding a GCF. GCF stands for greatest common factor. Today, we're going to talk about factoring a GCF. Okay? Factoring a greatest common factor. Okay? So I'm factoring a factor. So that's interesting. So everything in math that we do has an inverse. Okay? The inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication, division. And the inverse of division is multiplication. Okay? What about the inverse of squaring something? Well, that's square rooting. Okay? Do we have an inverse for distributing? We don't. So we actually have to talk about how I would do the inverse of distributing. So let's look at an example first. Okay? So 5x times 4x squared plus 3. Okay? I know I have to distribute in this problem because I have one set of parentheses and there's a number sandwiched outside my parentheses. So I'm going to go ahead and distribute 5x to 4x squared. What do you get? 20x cubed. If I distribute 5x to 3, what do I get? I get 15x. Okay? So my goal today is that when I give you this answer as your problem, how do I work in the opposite direction? That's factoring a GCF. It's the inverse of distributing. Okay, so let's take this as my problem, and let's see if I can work backwards. 20x cubed plus 15x. So the first thing you're going to do is to determine a GCF. So I need to find a GCF between 20x cubed and 15x. So the biggest number 20 and 15 have in common is 5. X cubed and x, they have an x in common. So my GCF is 5x. All right? So now, when you distribute something, do you multiply, add, subtract, or divide? You multiply. So since I'm doing the inverse of distributing, and with distributing I multiply, what do you think I'm going to do with the inverse? I'm going to divide. So I take both of these terms and I divide by my GCF. Okay? So now I clean up my pieces. 20x cubed over 5x is 4x squared. 15x over 5x is 3, and my x's crossed out. Look at this right now. Where do you see 4x squared plus 3 in the problem above? Notice it's in the parentheses. Now look. Notice your GCF 5x. Where is that in your problem? Oh, it's on the outside of my parentheses. So my GCF always gets written on the outside, and what I divided by gets written on my inside. So my steps: first, find GCF. Second, divide every term by my GCF. Okay. My notation always looks like this. You always have parentheses, and your parentheses are the leftovers. It's what you divided. And the outside of your parentheses is always your GCF. Okay? So let's go ahead and let's look at another problem. I'm going to take 16x to the 7th power minus 6x to the 3rd power. My directions would say factor a GCF. So the first thing I'm going to do is I'm going to come over here and I'm going to look for a GCF. So looking between 16 and 6, what's the biggest number they have in common? 2. Looking between x to the 7th and x to the 3rd, what's the GCF? X to the 3rd. Remember last class we said it's always the variable with the smaller exponent is my GCF. So I found my GCF. I'm now going to divide everything by 2x cubed. Okay? So 16 over 2 is 8. X to the 7th over x cubed is x to the 4th. Minus 6 over 2 is 3. And my x cubed slice out. My leftovers always are in parentheses. And my GCF is written on the outside. And I'm done. you wanted to check your answer, how could you check this? Well, you would distribute it back in to make sure it matched that. Okay? Let's look at another one. 8y to the 5th power minus 12y to the 3rd power plus 4y. Okay. I now have 3 terms. So I'm going to find the GCF of all 3 pieces. 8, 12, and 4 all have what in common? 4. Y to the 5th, y to the 3rd, and y all have a y in common. So I found my GCF. What do I do next? I divide everything by 4y. Okay, so 8 over 4 is 2. Y to the 5th over y is y to the 4th. Minus 12 over 4 is 3. Y cubed and y make y squared. Plus 4y over 4y, those cross out. What are you left with? 1. My leftovers go in parentheses. My GCF goes on the outside of parentheses. I circle my answer. I'm done. Let's look at another one. 9k to the 4th plus 12k to the 3rd minus 6k squared. I want you to pause this video and I want you to try this problem on your own. So the first thing you do is you find the GCF. 6, 9, and 12 all have 3 in common. K to the 4th, k to the 3rd, and k to the 2nd have k squared in common. I'm now going to divide everything by 3k squared. So now I have 3k plus 4, set the squared, 3k squared plus 4k minus 2. And k squared is crossed out. My leftovers go in parentheses. Who gets written on the outside? My GCF, which is 3k squared. Now, try this one. 16z to the 8th power plus 8z to the 6th power minus 4z to the 4th power plus 2z to the 3rd power. So go ahead and pause this video and then factor this on your own and then we'll go over it together. My GCF would be 2z cubed. So when you divide everything by 2z cubed, you're left with 8z to the 5th plus 4z to the 3rd, minus 2z plus 1. That goes in parentheses. They're my leftovers. On the outside is my GCF. And I'm done. With this, we have 2 special cases we have to talk about. Okay, special case number 1. Let's look at this. 2x squared minus 3x plus 4y. Find the GCF. What do you notice? There isn't a GCF. So when there isn't a GCF, what's the only number that goes into everything? 1. Okay? So if you divide everything by 1, what's going to happen? All your terms are going to stay the same, and it's extremely unnecessary to do this. So when you have a GCF of 1, your answer, you write the word prime, meaning this is a prime polynomial, or you write the word unfactorable. That means I can't factor it. All right? So let's write this down. Since the given terms do not have anything in common, the GCF is 1, and my answer is prime. Okay? often do you think this is going to happen? Not very often. But could it happen? Absolutely. So you got to be careful. So now, let's look at special case number 2. Special case number 2 tells me the leading coefficient cannot be negative. Right? So if my leading coefficient is negative, I have to take out a negative GCF. Okay? Leading coefficient. So if I write down an example, let's talk about leading coefficient. Negative 4x cubed plus 8x squared minus 6x. My leading coefficient means it's my first term. Okay? My first term can't be negative. So when it is negative, my GCF is going to be negative whatever else that comes out. Okay? 4, 8, and 6 all share a 2 in common. X cubed, x squared, and x all share an x in common. So now I'm going to go through and I'm going to divide everything by negative 2x. Because that'll turn my leading coefficient positive. Okay? So I get 2x squared minus 4x plus 3. Those are my leftovers. Negative 2x is on the outside, and I'm done. You know you're done because you have your leading coefficient inside parentheses is no longer negative. Let's look at another one. Negative 12y to the 4th minus 18y to the 3rd plus 24y squared. So, okay, I see a leading coefficient's negative, so I know my GCF is going to be negative. 12, 18, and 24, they all have a 6 in common. Y to the 4th, y to the 3rd, y squared, have a y squared in common. So I'm now going to divide everything by negative 6y squared. So negative 6y squared goes on the outside of parentheses. So now I'm going to clean it up. I'm left with 2y squared plus a negative and a negative make a positive. 8 divided by 6 is 3y. 24 divided by negative 6 would be negative 4. Y squared and y squared, they slice out. I'm done. Okay? So when you are factoring, your GCF, your lead, is positive unless your leading coefficient is negative. Your first term must always be positive when you are factoring.